In this video, I'm going to go over accessing an NMR spectrometer remotely for Pchem Cloud Lab. So we're going to jump right in to using AnyDesk, which is a virtual network connection, which is one of the primary ways we access remote instrumentations. And this has been covered in prior videos. So this is assuming you're already familiar with accessing using virtual network connections. So jumping right in, this is already logged in with my AnyDesk client to the Magnetic Resonance Research Center Bruker 400 NMR. This is the AnyDesk alias, and the password is given to ASU Online remote students or people sending in samples for remote research. If you need the password for this, you can contact the Magnetic Resonance Research Center at Arizona State University, which you would do to be sending your samples anyway, or if this is class related or Pchem cloud related, you can email biopchem@gmail.com. And that's exactly what you would email if you do not see more or less this exact view up. If windows have been closed, if things have been logged out, if the instrument isn't in this kind of working order, if different software has been, then you can email and the system will be reset. So we have live views, several live views of the instrument. It's running Icon NMR. The top window where the live views are overlaid is where you would use if you were in person doing a walk-up experiment and entering the information to put a new sample into the auto sampler. We're covering remote access of this system where you would be sending the sample and it would be put in for you, or students where these samples have already been made and put in the auto sampler. So we're going to focus on Icon NMR by Bruker. We're going to focus on this middle window, which is where samples have already been put in, and now we can do experiments on the samples in those auto samplers. And the bottom window is showing you what has been run in the past, how it's been run, what time it's been run, etc. So it's kind of a log of what has been done and what's coming up. Okay, so this is how you should see the instrument. Again, so this is the computer. We're kind of looking at it right here. So if we click different things, you can see it's a live view of this screen. The webcam on that screen is looking out into the rest of the lab where we can see the 500 megahertz Bruker auto sampler walk-up system, the 800 megahertz NMR, etc. in the Magnetic Resonance Research Center in ISTB1 at ASU. Then we have an overview of the spectrometer, the console, the magnet, the auto sampler that has the samples and moves it to put it into the magnet. And then there's a screen that kind of says, that gives you detailed summary of what's in the auto sampler, etc. So we have a webcam there where we can see it close up here. So we have samples in this square represents which one is in the position to go in the magnet. And then all of these darker ones means that there's a sample there. So there's an NMR tube in a spinner there. And then all of the open ones are ones that do not have samples. So we have 18 samples in the NMR. And those 18 samples are in holders 1 through 18, and they're listed here. They have explicitly given names, and more importantly, a lot of the details are provided in the text comment field so that you can remotely access and know what the different samples are in there. If you remotely sent a sample, you would be told what holder position it was in, and you would have the information about that sample, or if we made it, we would tell you what solvent we put it in, etc. Okay, so now just starting, why not here? So it's sitting at position 1, but we could look at if we wanted to run a sample, say this one, we wanted to run acetyl acetone in D2O. It's on this 400 megahertz NMR. All of the setups did a simple proton 1 scan at 298. And for this class, so all of these are for a specific class where we're looking at the physical chemistry, the equilibrium properties of diketones in different solvents at different temperatures, etc. So if we wanted to start by looking at this one, first of all, we would have this data, but if we wanted to run something, we could add an experiment to any one of these, but let's just do it to this D2O sample. So we can hit the add button. It copies a lot of the parameters from the one that's already been run. We're going to, of course, give it our own unique name. We might as well leave that it is ACAC or acetyl acetone. It's in D2O. It's on the 400. We're going to do a proton NMR, but we can select between any of these experiments that we want to do. So instead of doing the proton 1 scan, let's do something a little different. So let's set up and do an 8 scan to get better signal to noise. So then we'll change the file name to indicate that. So we're going to do an 8 scan, and we can do it at, instead of 298, let's do it at 300 degrees. So we're doing this. This is some information about us. So this is part of a video screencast. Example. And we're doing this on September 22nd, 2021. It increments the experiment number. So what you can do is you can queue up as many experiments on each one of the samples as you want and on each of the individual samples. This is in D2O, so we will leave that. If you don't give it the right solvent, it won't work properly. You can select between any of these experiments to do different types of experiment, kinetic experiments, different number of scans depending on what it is. You can look at the structure of it by doing different types of correlation spectroscopies, etc. We want to set the temperature. Instead of 298, we want to do this at 300, and maybe after that we'd want to do it at several other temperatures. And then it has a detailed information about the sample. We'll want to leave that. This is for so this is a remote, we're doing this as part of the video, so we'll kind of put that. It is on this instrument. These are 3 millimeter flame sealed samples. This is sample number 4. This gives details about what exactly that sample is. There's 250 to 300 microliters. It's sealed and it has a very specific weight. This is part of a video, so we don't really need that. We're going to do a proton, and then we're going to do 8 scans on the 400, and we're going to do it at 300. So this is obviously all optional. This is just so that we have as much information about the sample all contained within the data that we'll have. So we'll set that as the information here. And now we've added that experiment. Now it's ready to run. So it is doesn't currently have anything running. You'll see how that changes. So we can now submit that. And it will submit that. It will now come down here and submit that sample. We'll also see that it turned green there. It moved the auto sampler here to position 4. It's putting that into the magnet. It will then get the temperature at 300, tune and match the probe. lock, shim, and run the sample. So it takes usually several minutes to sometimes several hours to run things, and you can queue as many experiments on as many of the different samples in the auto sampler as you want. So when this data is done, we will have it where it automatically, for class, uploads to the cloud, or for researchers, it uploads to Spectrometer, our cloud service for accessing the data. You can access the data locally, but again, the primary objective is to collect the data, and we have services to automatically get that data to you. We will have different videos about how to process this data offline, etc. But that shows you initially how to set up an experiment on this. For completeness, let's go ahead and do one more to show that while that one's running, we can set up another experiment. So we're running that one on D2O. Let's go down one sample. We could choose any of these, but let's run it on one that is H2O so that we can see the hydrogens that are exchanging. And the common trick in NMR is in D2O, when you have exchangeable ones and they exchange for those deuterium and now they become proton NMR silent, is to put it in just a small amount of D2O so that it can still lock, but primarily H2O so that the exchange is with hydrogen and it would still be observable in the NMR. So again, all of these have been put into the NMR and had a one scan test setup sample run on them. So from here, we can highlight that one and click add for add a new experiment. We will on this one, let's do the same thing. Let's run a proton presat experiment at 300 Kelvin. So what do I mean by that? So our solvent is 90% water, 10% deuterium. It's going to have a very large water signal associated with it. So we can do a water suppression technique to remove that. That would be a typical, so we could call it, just so we stay consistent, we could say water suppression. 300, we are going to call this the same. We'll call it video screencast example, same date. So now we have a very detailed name. So that'll be the directory name or file name it gives it. It's going to move into experiment 12 to run this. So it's incrementing experiment number. You could move it into another one, but usually you just let it increment. The main thing you want to do is give it a unique and descriptive file name and choose the experiment you want to do. Make sure you're at the temperature you want to be at. You can be anywhere between room temperature and 50 degrees Celsius. So 298 to 323 or so. So we're going to go to 300 again, just a little above room temperature. And you want to make sure that you've given it a pretty explicit name. And so in this case, again, we'll call it remote NMR. Just to be consistent, and this tells you, we will leave all that, which tells you about the sample. You don't need this information. And we're running a water suppression, 400 megahertz NMR, and we're doing it at 300. So we can set that as the title. We can highlight that experiment and hit submit. Now it will it's yellow. This one's still green, meaning it's still running. This one is yellow. It will run when the next one is done. You can see it checks through it. So the one that we set up earlier, which is here, is sample 4, is currently being run. It has been loaded into the NMR. It has already had its tune and match. It's locked, it's shimmed, but it hasn't acquired or processed the data yet. So when it does finish that, it will then put the sample, take it out of, eject it out of the magnet, put it back into sample 4. It'll move over, put sample 5 in, and do the process of running the experiment we asked it to, which in this case is running this water suppression proton experiment. So now you can log out after you've set up all the experiments, and the data will be on the cloud accessible for you. And again, there are separate videos to talk about processing data, which can be done completely offline. If there are any problems with collecting the data or getting a sense for how long it's going to take, usually things are run within several hours of queuing them up. But obviously it depends on how many samples and what has been queued up. You can look at, with this status to see how many things are in yellow, or how many things in a sense have been queued. So you can see here right now, there's nothing else queued. We have our one experiment that's running right now in green, and we have one here in yellow that's waiting. So we can estimate that as soon as this 8 scan is done, which will take about 10 minutes, then it will run our sample, or our next sample that we've queued up. You can queue up as many experiments on a single sample, so we could add another experiment. For example, after we did water suppression at 300, we could add an experiment again here and do a carbon, or we could do another preset at a different temperature, or so you could queue up as many experiments within this as you want. If you started one and you don't want it, you can delete it. Or we could go down to another sample and set up this one. Okay, so hopefully this video gives you a sense for how to access and start and queue up automated NMR experiments for remote NMR running of an instrument with samples that are loaded into these automated sample jets. Thank you.